Hello all, thanks for the opportunity. My name is Sadgunan. So my project is based on the AI-based computer vision to analyze the overhead image or the satellite image. So yeah, let's go into little detail. So basically, I'm using the data sets which is publicly available. So which is called by name XView. So XView has around the thousands of images and it has around 60 classes, distinct types, which is based like a bus, cars, truck, etc., boats, etc. So totally we have around 1 million properly labeled object, which covers around 1,400 square meters of the earth surface. So yeah, so this is a dataset overview. So what I have used in my architecture. And yeah, so next it goes to architecture. So basically the this is a workflow, the satellite image datasets which I'm using the XView, and I'm using a deep learning framework called PyTorch with the TensorFlow, and I'm using a document algorithm which is based on the CNN. So we have many convolution layers here, and finally we get the images with the object detected in the images with their bounding boxes. Uh, so now let's see the results in the video. How I done it in the server side. So basically this is a the training set what I have already explained to you. We have hundreds of images, right? So this is one of the example of the XView data set image set, and yeah, maybe the second image is uh, yeah, second image is this one, and the third image, yeah, this is just to get an idea of how the training sets looks like. Now let's look into the coding part. So basically, as I told you, I have used the PyTorch for my coding stuff. So this is how my the framework looks like. So basically, I'm using the CNN algorithms, and the result of the algorithms or will be found in the result.txt file. Yeah, let's open the txt file where you could find the log of my model, where you could find the number of epochs, what is the accuracy we get, and what about the recall and the true positive, and all such informations could be found here. The second point is about the PT file, the model file. The output of the model file is a PT file, so where we store the PT file. So basically we use this PD file to inference our images. So basically we use this best.pt and we give the test image, and we could find the results from this file. Yeah. Yeah, so basically this is the Python file. Where you can see the direct.py, where it could take the images and input, and the result will be written in the txt file format. Yes. So the output you can find it in this folder called output.txt file. So where in the txt file you can find the where you can see here the number of lines where you could find the bounding boxes with the proper labeling structure here. So these are the output from my model. So what we do next is the output of the images which could be found in this folder. So you can find here the images with properly labeled. So this is one of the example for the building image where you could see the buildings are properly labeled. So I will zoom this in the Internet Explorer. So let's can see the yeah the motorboats are perfectly detected in our image set. Yes, so this is one of the output of from the image. Example where I could find the dump truck. So let's zoom out and check. Uh, so let's yeah, this is one of the example of bus. So let's see the buses are getting detected. So there are no bus detected. Okay, so let's go for the building. Yeah, building is one of the best example. So you can see here the lot of buildings are getting rated here in this image. Yeah, so this is one such example, and let's see whether any small car is rated. Yeah, let's zoom in. Yes, there are few small cars which getting rated. So yes, so let's see any trucks getting rated. Yeah, there are few trucks getting rated in the down. Yes, it says this is a truck. Yeah, it looks like truck. Let's see here. Yes, this is also looks like truck. And then look for the any cranes here. So let's zoom out. Yeah, there are the container cranes here. So let's zoom in. Yes, out of which you can see there are four containers, but it detected only three because one looks little different here. So that's good. Yeah. So but it detected the container crane. Yes. And engineering vehicle. So there are any engineering vehicle? Yes, it says this is an engineering vehicle. Okay, fine. Okay, good. Uh, okay, okay. Any crane truck? It says it's a crane truck. Okay, good. Yeah. So those are the examples we have seen here. So yeah, this model is performing definitely satisfactory. To improve the accuracy, we need to train it more. Yeah. So to summarize, so what we have done is, so we have used the XView satellite image to train our model architecture, and we have used the CNN, and which detected object to the satisfactory level. And I have tested with the XView data sets, and it's giving the very good results. So what we can do more is we could train with the more data, or we could train with the more number of epochs, so that we could improve the accuracy, and an application could be developed to view it properly, and a few if there are any proper use cases is there, we could definitely customize this architecture, and we can develop the application on this. um, so that's it from my side. So that's it from my side. Thanks for the opportunity. Goodbye. Thank you.